The Fermi paradox. Where are all the aliens? Our observable universe is vast, with an estimated 2 trillion galaxies, each containing anywhere from a few million stars to billions of stars. Based on the only known observation of life in the universe, our own, after an energy source, liquid water is considered the most important ingredient for life. The region around a star where water can exist as a liquid on a planet is known as the habitable zone, and the planets within this region are known as habitable planets. The trillions of stars in our observable universe contains trillions of habitable planets that orbit them, and this in turn means that there have been trillions of chances for life to have developed across the universe. And this leads us to ask, where is everyone? During a discussion with a group of fellow scientists, Enrico Fermi asked that very same question. And the lack of any evidence of any form of intelligent extraterrestrial life, along with the assumption that the universe should be teeming with alien civilizations, has come to be known as the Fermi paradox. The local group. The local group is a group of galaxies containing our own Milky Way galaxy and a number of other galaxies and dwarf galaxies, all bonded together by gravity. Everything outside of our local group is unreachable to us, even if we were able to achieve light-speed technology in the future. This is because everything outside of our local group is speeding away from us faster than the speed of light, owing to the influence of a mysterious dark energy. So instead of focusing on finding alien civilizations in the universe, let's scale it down to not even the local group, but down to just the Milky Way galaxy. Some estimate that if advanced civilizations are able to build spaceships that could sustain populations for generations to come, then these civilizations could colonize the entire galaxy within 2 to 10 million years. Drake's equation. In 1961, Dr. Frank Drake came up with the Drake equation, a mathematical formula that attempts to use all the factors we assume will come into play in estimating the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. Let's go through each part of the equation one by one. N equals the number of detectable civilizations that should be present in the Milky Way galaxy. This is found by multiplying the following: R asterisk, which is the number of stars formed each year; Fp, which is a fraction of those stars with planetary systems; Ne, which is the number of planets per solar system with an environment suitable for life; Fl, which is a fraction of suitable planets on which life actually appears; Fi, which is a fraction of life-bearing planets on which intelligent life emerges; Fc, which is a fraction of civilizations that develop a technology that releases detectable signs of their existence into space; L, which is the length of time such civilizations release detectable signals into space. Let's talk about inserting some numbers into this equation and see what we are dealing with. Some claim that based on the lowest estimates, the equation seems to indicate that it is highly improbable that we are the only intelligent civilization to exist in our galaxy. But the major criticism is what we are presuming to be the lowest estimates. We only have one example of life to work with. We are making presumptions on how likely it is for life to develop, for intelligent life to emerge, for that intelligent life to create advanced technology, etc., all from our one known example. This leads us to look at the Great Filter Theory. The Great Filter Theory implies that one of the steps between the formation of life to the colonization of the galaxy must be highly improbable. Let's chart 4 major steps in this evolutionary path and look at them more closely. Step 1. Abiogenesis, the original evolution of life. Step 2. Development of complex multicellular reproductive life. Step 3. The leap to intelligence. And Step 4. Colonization of the galaxy. Abiogenesis. We have no clear idea of how inanimate chemistry developed into biology. Also, as far as we can tell, All living things in our world are related, and we trace back to only one origin of life. Does this mean that life is extremely rare? So rare that it happens once in every galaxy, or even so rare that it is a unique event? That could very well explain why we have no indication that there are aliens out there. Development of complex multicellular reproductive life. Life may exist on a number of planets, but for that life to have become complex, multicellular, and reproductive means that a very specific set of conditions must have existed or developed. Perhaps what has happened here on Earth is not as commonplace as we imagine. The leap to intelligence. We have plenty of examples of life surrounding us on our planet, but we humans are the only intelligent life forms that are looking to communicate with extraterrestrials. It's highly unlikely that other planets would host aliens that are exactly like us. So what is the probability that those aliens would develop intelligence and the urge to communicate? Let's look at the animals here on Earth, for example. Are there any species that are likely to develop intelligence similar to us? Is intelligence evolutionarily convergent? Convergent evolution is the independent evolution of similar features in species of where those traits were not present in their last common ancestor. An example of convergent evolution is the eye in both cephalopods, such as squids and octopuses, and vertebrates, such as us. Will evolution decide that intelligence is a similarly beneficial feature to all creatures? And in 100 to 200 years' time, can we expect crows and dolphins to evolve a level of intelligence that bears any resemblance to our own? We don't know, but if they did, it would make the idea of intelligent aliens more likely. Colonization of the galaxy. And finally, we turn our attention to the colonization of the galaxy. All the other great filters are behind us, but this one may lay before us. Is there something that happens to all intelligent civilizations approaching the ability to develop technology that lets them travel and colonize the galaxy, that sets them back or destroys them entirely? Something like an asteroid colliding with the Earth, leading to mass extinction, or nuclear war, or out-of-control climate change that makes the host planet uninhabitable. Types of civilizations. Civilizations are broadly categorized into Type 1, Type 2, and Type 3 civilizations, based on the amount of energy a civilization is able to use. This scaling system was first proposed by Russian astrophysicist Nikolai Kardashev, and it is known as the Kardashev scale. A Type 1 civilization can use and store all of the energy of its home planet. A Type 2 civilization can harness the total energy of its home planet's parent star. In our case, this would be the ability to harness all the energy of the sun. The way to do this would be to use a Dyson sphere, a hypothetical device which would encompass the entire star and transfer its energy to all the planets the civilization has colonized. And a Type 3 civilization, also called a galactic civilization, can control all the energy of its entire host galaxy. Humans have not yet reached Type 1 civilization status, and we're estimated to become a Type 1 civilization in a century or two. But there's a huge leap between Type 1 and Type 3, and the Great Filter theory, which we have discussed earlier, questions whether there is something between the two that stops Type 1 civilizations from developing into a galactic civilization. Other solutions to the Fermi paradox. There are a number of other potential solutions suggested for the Fermi paradox, from the simple to the more fanciful, and we'll explore some of them now. Aliens have a more appealing virtual reality. Advanced alien civilizations may have developed a virtual reality in which they prefer to spend their time over searching for other life forms in the universe. We are uninteresting. We are uninteresting to an advanced alien civilization, and while they may be aware of us, they may not think that we are worth their time. They may view us the way we view ants, interesting, but not interesting enough to try and communicate with. Communication problems. Currently, we are transmitting radio signals in an attempt to connect with extraterrestrials. But how likely is it that they are using that exact same method of communication, or that they can even understand that form of communication? Perhaps we are too different to even effectively communicate with advanced alien life forms anyway. We can't even communicate with most of the animals on our planet, so how can we expect to be able to do so with extraterrestrials? We may not be around at the exact same time. If advanced alien civilizations are extremely rare, we may not exist at the same time with the appropriate level of technology on both sides to make contact. Or we may not even have been looking for long enough. Simulation theory. We live in a simulation, a great matrix, and we are the only sentient beings programmed into this simulated universe. This begs the question why the creators of the simulation decided to create such a huge universe if all they wanted was for us to exist as the only intelligent communicating life forms in it. Zoo hypothesis. The zoo hypothesis imagines that an advanced alien civilization is watching over us, and when the time is right, they will make contact. Very much like the plot of the movie 2001: A Space Odyssey. The super predator theory. This theory imagines that an alien civilization has become a Type 3 civilization that annihilates any future civilizations that come close to attaining Type 2 or further capabilities in order to remain the dominant civilization in the universe. Or maybe an even simpler explanation is the reason why we've not made contact with aliens, in that we are the first. We just happen to be the first intelligent civilization to have appeared in the galaxy. And that concludes our explanation of the Fermi paradox and our exploration of some of the potential solutions to the paradox. As always, I hope you enjoyed this video. Please support this channel by subscribing and turn on the notification bell for more interesting and educational videos from me.